Hello there, and welcome back to City College of San Francisco's Alternative Energy class. And I, Professor Synergy, am here to join you again. You see behind me this fiery ball. It is the sun. And so we're going to talk about solar. Okay? I'm going to introduce the solar videos. I think in this one video, I'm sorry, it's the solar modules. In this one video, I'm going to cover 2 solar modules. Kind of do it a little quickly. And hopefully it's not too fast, but if it is, you guys can let me know. This is actually an old video. I'm going to leave it here if anybody's really interested in it, but I bet it covers the same content I'm talking about here. So, big numbers. The sun, it's far away, it's massive, and a lot of crazy stuff happens in it. Make sure you read through it. Talk a little bit about radiative flux, irradiation, insulation. Now is when we need to start really taking Boyle or Peake seriously. So Peake is the new author of our book by Boyle. It's the renewable energy book. It's the physical book you have to buy. Unfortunately, it's not free. Please, there are some important readings that need to happen in that book. So make sure you're doing that in this week. The other thing I think that's really cool here is this explanation around heat and how we get energy from the sun. Make sure you take a look at that. Most of us may not be familiar with that as well. And here's just a fun diagram about the atmosphere and sort of give you some scale of how big the atmosphere is compared to, say, Mount Everest, which we all take to be a pretty big thing, I believe. Then we dig into looking at US insolation in detail. So insolation is a fancy word for the energy coming from the sun and striking the earth. And you'll notice it's insolation. It's not Owens Corning. It's not the Pink Panther. It's not that stuff you put in your building. It's insolation, and the sol actually is the word. It has its roots in the word for the sun. So we talk about a bunch of different insolation here. There's also a couple maps. Please make sure you try to understand these maps. There's a bunch of questions about these maps and the comprehension checks. Make sure you get to know them. Yeah. And then here we introduce efficiency in the context of solar. Okay? This efficiency equation is no different than the efficiency equation you already saw. It's just being applied to solar. And the efficiency equation never changes. It just gets applied in different ways. Okay? We'll talk a little bit about solar. You hear people say it's intermittent, doesn't show up at night, blah, blah, fluctuates, well, whatever. We're getting well beyond that. If you look at solar deployments, you look at the cost of solar, it's amazing the progress we've made. And you'll hear this again and again from me over and over. I just wanted to re-highlight that here. And actually have a couple articles that come up here. These are 2 articles that were in Science. And I had the fortune of meeting the author, Nancy Hagel. She's from the National Renewable Energy Lab, which the maps are produced by them as well. And they've been tracking solar for some time. And it's really cool what they have observed. And I believe I talked about this plot earlier in the semester, and I want to make sure that you guys understand this plot is super important to me. I think it's very important because the core message of this plot, and make sure you understand how that's interpreted. The core message of this plot is our predictions continue to be wrong. And they continue to be wrong in a good way. We predict so much amount of solar, and then the real amount of solar that gets installed is greater than that. Then again, we predict real amount of solar, so we predict more solar installs, and then the real amount that gets installed is even greater than that. And that's what we're trying to show here. This black line shows real solar, and the trajectory is just amazing. Now, things are changing. There's economic hardships around the world, and it's to be seen what impact this has on the renewable energy industry versus, say, some of the other industries, which are also energy industries that are struggling immensely right now. There was an update last year to this same series, sort of same themed article. Also, you'll notice the same author, Nancy Hagel. So please take a chance to read, please take the opportunity to read both of these articles. And they're not super long. They're relatively, as far as journal articles go, they're easier to read. But they are going to challenge you. They're a little bit harder than my reading. So what I write in the modules is not the same. And they're harder than what you see in McKay or Peake or Boyle. And that's okay. I don't expect you to understand 100% of what you read here, but if you can get at least the gist of it, the core value, the core message out of it, that's good. If at any point there's a question about these articles, please post a discussion post. Tell me exactly which article it is. Tell me which page, which column even. Sometimes it's super helpful. Be as helpful to me as possible so I can also be helpful back to you. Which may sound, you've heard it before, but it's surprisingly not as intuitive and obvious to everybody as you would think. This gets into our next module now, where we're going to really dig into specific solar technologies. And Boyle does a good job, again, talking about these. Make sure you read Boyle. There are 3 ways of thinking about solar. I like to think about solar in 3 ways, and that is passive solar and active solar. And these tend to be in the low temperature realm. Next week, we're going to talk about concentrating solar power. That is high temperature solar. Yeah. And then the third one is photovoltaics, PVs. And we're going to talk about that in a couple more weeks. So these are 3 main ways of harnessing solar. It's low temperature solar, high temperature solar, and PV. These are distinct basically based on their technology, the complexity of technology, and what you can get out of it. Here you can see something that doesn't look very high-tech, and it's not that high-tech. It's really basic, simple stuff. This is an example of a thermosiphon, which I want you to make sure you understand. These are all thermosiphons. And if you can, please, I'm sorry, not if you can, you need to make sure you read that in Boyle and understand a thermosiphon. Here's some guidance on Boyle reading, but you need to read it all per the Canvas module. Here are some diagrams that can be helpful. These discuss flat plate collectors. This one especially, I think is a solid one. Make sure you understand this one. Notice this is a flat plate collector for solar hot water. So this water is moving through here, not electricity. There's no electricity in this at all. No moving parts at all. This is just a flat plate collector trying to capture solar energy to heat water. It's amazing how well these actually work. It's amazing how well they work. I've been in places where they work really well. I've been out in the middle of nowhere, kind of sort of not exactly camping, but in cabins where this has been the hot water source has been made. This discusses the thermosiphon. It's really great device as well. I feel like it's one of those things that we should start using more broadly in this country, but we have yet to do so. Yeah. And that takes us to the next lecture, so we'll stop right there. Thanks again for joining me with this fiery sun behind me. Again, don't worry, I'm safe, nowhere near it. Although we did send a probe quite close to the sun, the Parker probe. Those of you who are curious, you should look it up. All right, thanks again for joining me. I'll see you soon. I do have all my fingers here, although Zoom makes it look like I don't. I'm doing a little Spock action for you. I'll see you next time.